what if the universe isn't telling us the whole truth? We've been taught that nothing can move faster than light, that it's the ultimate speed limit baked into the fabric of space and time. But some equations whisper otherwise. They suggest the existence of a particle so strange, so fast, it doesn't just outrun light. It may even outrun causality itself. This particle is known as the tachyon, a concept born from the mathematics of quantum field theory and special relativity. Tachyons travel faster than light. In fact, they only exist beyond this cosmic speed limit. And because of this, their behavior turns everything we know about time upside down. Tachyons don't move from past to future. They move backward in time. They arrive before they leave. They cause effects before causes. No experiment has directly observed a tachyon. But despite this, the idea persists, like a shadow just beyond the reach of observation, lurking at the edge of our theoretical frameworks. And if tachyons are real, then time, motion, and causality, the very pillars of physics, might not be as fixed as we believe. To truly understand why tachyons could exist, we must go back over a century. In the early 20th century, Einstein's theory of relativity introduced the concept that nothing could exceed the speed of light. As an object with mass accelerates, its mass increases. At light speed, the energy required becomes infinite. Therefore, no massive object can break that limit. But what if a particle never needed to slow down? What if it was born faster than light? In 1962, physicist Gerald Feinberg proposed a particle that could exist only at superluminal speeds. In his model, the tachyon had imaginary mass, not imaginary as in made up, but imaginary as in a number multiplied by the square root of 1/1. This idea might seem absurd, but in physics, imaginary numbers aren't fiction. They're used in wave equations, quantum mechanics, and even in electrical engineering. Tachyons are not supposed to be detectable in the normal sense. Instead, they appear as mathematical artifacts in quantum fields. They're not real in the traditional sense, but their existence could signal instability in a field, prompting it to evolve to a more stable configuration. In string theory, the appearance of a tachyon means the vacuum state is unstable. The universe wants to roll into a more stable shape. In this sense, tachyons may not destroy physics. They may help refine it. But here's where things get wild. If a tachyon could carry information, it would allow communication backward in time. This violates the principle of causality, the idea that causes precede effects. If you could send a message to the past, you could warn yourself of danger or cause paradoxes. Like the grandfather paradox, what if you prevented your own existence? That's why many physicists are cautious. Most theories that include tachyons carefully limit their effects so they can't transmit usable information. They're often called virtual particles, part of internal processes in a quantum system that can't be directly measured. Still, the idea refuses to vanish. Tachyons appear in speculative physics, in some versions of brain cosmology, and even in theories trying to explain dark energy or the inflationary period of the early universe. And for science fiction, tachyons are everywhere. From Star Trek to Doctor Who, tachyons have been used to explain time travel, cloaking devices, faster-than-light communication, and paradox resolution. But even though no real experiment has yet proven their existence, tachyons continue to provoke, forcing physicists to question the very structure of time and space. Are they real? Or are they simply a symbol, a hint that something bigger, stranger, and more beautiful lies just beyond our current understanding? In the end, whether tachyons exist or not, their ghostly presence reminds us of a vital truth. The universe may still hold secrets beyond the light.